Hello, today I'm going to start with solving a simple equation. First you want to think about how you're going to divide by x to the negative third power. So let's just start with something simple. Let's do x to a times x, change that, x to the b. And of course, you're not going to make it 2x, but a simple property of xa plus b, when you can just also say that equals x. Just erase that. So you see that, and now you want to look at how you would do it with a negative. So xa times x to the negative a would equal. Now, you could obviously see that if you're going to add it, it'd be a plus negative a, so you have x to the a plus negative a which is also equals, a is not very good, but that's an a, equals x to the 0. Now, as you can see, you cannot, x to the 0 is not as you think it is. It's not just x times 0. It's different, and it has different properties. And okay, so we've gotten that x times 0 does not equal 0. And let me explain. So let's put an example here. X times the power, let's say y, times x to the 0 equals, now if you think about it, you would add y plus 0, because it's x to the y plus x to the 0 plus 0. So because as we've seen here, the general rule of thumb is that if you multiply the same coefficient, so your x is still the same on both sides, but then you have different variables and you multiply the same exponent, you multiply them together, they just add. So here we just have equals y plus 0, and that's a small 0 and a small y. So there we go, y plus 0. Then you think about that, that just equals x to the power of y. Because the 0 is 0, so you don't see it almost. It's always got the invisible 0 in there. So if you think about it, if x to the power, let me rewrite this better, power 0, not times, x to the power 0 does not equal 0, because if it did, you'd be multiplying 0 here. There's a big x to the power 0 by a number. That would just give you this whole thing would be unnecessary, and they would give you 0. So basically you get your whole equation to 0, and it would be 0. Saying this was 0, but it's not. And if you think about it for a minute, what else are you doing here? Alright, so you concluded that x to the 0 is not 0. And if you think about it, let's just put a different variable in for a second. X to the y times, let's say, an uppercase B just because I want to use an uppercase B equals x to the y. Because if you look at it right here, we're timesing by next to the 0. And we're getting the same thing. So x to the y times x to the 0 still equals x to the y. And x to the y times b is equal to x to the y. And along the property you've seen before, anything times 1 is always itself. Therefore, b in this case, b would have to equal 1, and x to 0 equals 1. So let's just put in something as an example here. Let me just get another color. I'll underline this. It's an important thing. I'll also underline this. So let's go in, for example, x to the a times x to the negative a equals. Now, you can think about it in your head already. A minus a, so any variable minus itself would equal 0, so therefore you get x to 0. Which is x to 0, which is also equal to 1. So you can just say 1. Just going to mark out this part. It equals 1. Now, let's say you wanted to find what this x to the negative a was. So you put it in that it equals, let's just do this real quick, equals 1, because we know equals 1. And we're just going to solve. So let's divide this side, ix to the a, this side, x to the a. And we get x to the negative a equals 1 over x to the a. Now, if you just think about it for a second, wouldn't that just mean any negative variable for, let's say, x is equal to the opposite of the reciprocal, because we have x positive, so it's 1 over x to the positive a. So that just equals the opposite of the reciprocal. So let's go back all the way, let me get a different color, all the way over here, and let's look at this problem. So we have x to the negative 3. Now we know that x to a negative number is equal to the opposite of the reciprocal. So let's just put it in. 2x squared, and here opposite of the reciprocal, divided by y in it over x to the third. These are the same things, if you think about it. Now, of course, you're dividing by a division, so you therefore have to flip it and multiply, so 2x squared times x to the third, because you flipped it. And now you have 2 x to the second, x squared times x cubed, which is also, as we've seen right here, equal to, and the 2, by the way, remains the same, if you're wondering, 2 times x to the fifth, because you could add the two variables. So let's just do a recap right here. This is our original problem, 2x to the square over 2x to the negative cube. And we're going to just put in a very important property right here, which I'm even going to underline one more time, just because that's extremely important. X to the a times x to the b is always equal to xa plus b. You just add the exponent. And then we were wondering what happens if you multiply x to the a times x to the negative a. Well, you think about it. Any number minus itself, saying the number itself is positive, equals 0. X to the 0. But we thought, well, we know, as I've explained here, it cannot equal 0. So we put it in for here. We have x to the y times x to the 0. Now we did x, y plus 0 as you should, and you get x to the y. X to the y times x to 0 does not equal 0, because if you notice, we just multiplied it here. We did not get 0. So we just thought about it for a second, and you do, let's just say, for example, b, x to the y times b equals x to the y. B, any number times itself, when it equals itself, let me rephrase that. If a variable, for example, x, is multiplied by another unknown variable and still equals x itself, so let's just say x times y equals x, we can conclude that y equals 1. And as here, b would be 1, because x to the y times b equals x to the y. And therefore, as we look up here, x to the y times x to the 0 still equals x to the y, therefore x to 0 equals 1. And as we've gone over here, x to the a times x to the negative a, we know that equals 1 because a minus a is 0, and x to the 0 is 1. And we wanted to figure out what x to the negative a would be. So we divided by x to the a on both sides, and we looked at our answer, and we just noticed that x to the negative a is equal to 1 over x to the a, or the opposite of the reciprocal. So you can, let's say, x to the negative fifth is equal to 1 over x to the fifth. That looks like x times 5, but it's to the fifth. So we went all the way over here to our main problem and looked at it. So we rephrased it, since x to the negative third is equal to 1 over x to the third. So we put that in place of x to the negative third, so 1 over x to the third. And then you know that when you divide by a fraction, you multiply by the reciprocal. So you get 2x squared, as in right here in the equation, times x to the third. Now, as we remember up here in this very important property, x to the a times x to the b would equal x to the ab. Therefore, you just add them, a plus b. So 2 remains the same, as if it's kind of excluded here. There's little hidden parentheses that aren't visible. It would be times x squared times x cubed, which is also x to the fifth. And that is all for our quick lesson. Thank you for watching, and I'll see you in the next one.